सब्सक्राइब कीजिए जेईई फिजिक्स को एंड बेल आइकन दबाइए लेटेस्ट वीडियो सबसे पहले देखने के लिए।
Can I use force as a fundamental quantity? Can I omit the mass from the list of fundamental quantity and use force as a fundamental quantity? Yes or no? I will answer it in my today's lecture. Hello students, I am Manoj Karmakar and you are watching my channel JEE Physics JEE NEET Guide. In the previous video, what I have discussed, it is mainly for 11th class written exam and not so important for MCQ. But in today's video, I will give you the answer that can I use force as fundamental quantity? So let's go to the question directly and I will give you the concept in question answer method. So question is given here that if force, time and velocity are taken as fundamental quantities, then what will be the dimension of mass? Sorry, here it is not velocity, is if force, time and length. If force, time and length are taken as fundamental quantities, then what will be the dimension of mass? So from the question, I see that mass is omitted from the list of fundamental quantities and force is taken as fundamental quantity. So we have to find the dimension of mass. Here is the solution. Very easy problem. It's not so harder. Now the dimension formula for force is, let our fundamental quantities are force which have dimension F, mass is not fundamental, time with dimension capital T and length which have dimension capital A. So we introduce here dimension of force as F. Force is taken as fundamental quantity and mass here is not a fundamental quantity. So what will be the dimension of mass? Dimension of mass. To solve it, we have to first write the dimension of force in our old system, that is in which the dimension of mass is m, dimension of time is t and dimension of length is l. Now dimension of force is given by F is equal to m l t to the power minus 2. So we can write m l t to the power minus 2 is equal to F, or m is equal to F L inverse T square. So we get dimensional formula for mass is equal to F L inverse T square. It will be dimension of mass if force, length and time are taken as fundamental physical quantity. Now I take a problem from H.C. Verma, Concept of Physics. The problem is, here it is. Which of the following sets cannot enter into the list of fundamental physical quantity? Option A, length, mass and velocity. Option B, length, time and velocity. Option C, mass, time and velocity. And option D is length, time and mass. Now, I have to discuss that if I change the set of fundamental quantity, then what are the criteria for a set to be fundamental? So I solve it. The question I am putting it at the corner. Let's solve it. So what are the criteria? Now look at the option D. In option D, it is given length, mass and time. So option D will not be answered because length, time, mass, these are the fundamental quantity which we use in physics. So it is used already, so it will not be the answer. Now take the option A. Option A is given length, mass and velocity. Length, mass and velocity. The dimension of length is L, dimension of mass is L, dimension of velocity is L t to the power minus 1. So we have L here, we have M here and we have T here. As we are getting three fundamental quantities from the set which we use in our system, then these three also can be represented as fundamental quantity. So suppose if the dimension of velocity is given by capital V and time is omitted from the dimension of fundamental quantities, then we can find the dimension of time. How? Time is equal to velocity is equal to length by time, so time is equal to length by velocity. Length by velocity, it is equal to L by V. So dimension of time can be written as L V to the power minus 1. If length, velocity and mass are taken to be fundamental physical quantity, then the dimension of time will be L V to the power minus 1. Now I take the option A is completed, D is completed. Option C. Option C is given here mass, time and velocity. Mass, time and velocity. dimension of mass is capital M, dimension of time is capital T, and dimension of velocity is let V. Can I find the dimension of length from here? Now length is equal to distance, length means distance equal to velocity multiplied with time. So dimension of length will be dimension of velocity into dimension of time. So length also can be find out from these three physical quantities. And we have the rest one option left, that is length, time and velocity. Now watch it carefully. Length, time and velocity. Dimension of length is L, dimension of time is T, and dimension of velocity is V. First of all, velocity equal to length by time. From the dimension point of view. So dimension of V is equal to dimension L by T, that is LT inverse. So we have three physical quantities which are fundamental, and one can be represented by the others two. This should not be the condition. It is the way to find out that three physical quantity can be used as fundamental or not. It is the answer that any of the physical quantity must not be represented by the others two only. Any of the physical quantity V must not be represented as L and T only, then it will not be the answer. There should be M. And another way, find the dimension of mass from here. Dimension of mass, length, time, velocity. No information of mass from the three physical quantities. So we cannot find the dimension of mass from here. And that is why this set cannot be taken as fundamental physical quantity. Okay. Let I take another problem from H.C. Verma. It is question number 6 of objective 1. The previous one was from objective 1 question number 1, and now it is question number 6, given that integration dx over 2ax minus x square is equal to a to the power n sin inverse x by a minus 1. First, look at the dimension. Let it has to be solved. Question is the value of n. The value of this n. Option A 0, option B 1, minus 1, option C it is 1, and option D, none of the above. What will be the value of n? We have to find it from dimensional point of view. Put the question at the corner. Okay. So, see. What I can do? Let x is distance. So dimension of x is L. Dimension of x is L. Now, if x is distance, then dx is an elementary distance, small distance, very teeny small distance. So dimension of dx also L. Look at this physical quantity, 2ax minus x square. As x is length, so dimension of x square is L square. Here the dimension of x is L. Dimension of A we don't know, and dimension of 2 is nothing. Now, in my previous video or previous lecture, I told you that if I have minus sign here, then in the both sides those quantities must have same dimension. So here ax must have dimension as x square. If you not gone through the previous video, you can watch the video by pressing the bell icon. By pressing the I button at the above. So from here it is L square, it is L to the power 1. So dimension of A should be of L. So dimension of A is also L. Okay. So the whole physical quantity, not physical quantity, I don't know. The whole quantity expression have dimension of L square. It whole dimension of L square. So if I put under root, then dimension becomes L. So now I am in the stage of writing the dimension in the left hand side. Now if I find the dimension of the whole quantity in the left hand side, then it becomes L over L. dx has dimension L, root over 2ax minus x square has dimension L. So the left side is dimensionally 1. So must be in the right hand side, because there is equal sign. Press the I button and go to the previous video. You can see that I told you that in the both side of equal sign, quantities must have same dimension. So this quantity also should be dimensionally 1. No dimension. Now here x by a. X has dimension of L, a also dimension L, so dimensionally this is dimensionless. 1 is also a number, a dimensionless, so the whole term is dimensionless. And here we get, therefore, left side have dimension 1, right side dimension of A is L, to the power n into 1, or L to the power n is equal to 1 is equal to L to the power 0. Therefore, value of n is 0. You can check in your mathematics book that all the formula of integration are dimensionally correct, and you can remember them by this method.